In this problem, we have a function 6 root x minus 10x, and we are asked to find the absolute maximum and minimum on the interval 0 to 4. Now, normally when we're finding maxes and mins, all we do is we take the derivative, set it equal to 0, and then we can test those critical points to see which is the max and which is the min. But in problems like this, we could have the smallest value on that interval actually be something different than the minimum. Let me just give you a simple example real quick. So, in this problem here, we have a local minimum right there, but the actual lowest value is on the endpoint over here, even though it's not a local minimum. So, to solve problems like this, all we have to do is find the critical points and the endpoints, and we just test all those values, see which one's the largest and which one's the smallest, because those endpoint values could be higher or lower than the actual maximum or minimum. So, I'll show you how to do this one. So if we take the derivative of f of x, we get f prime of x is equal to, and to make this a little bit easier on ourselves, I'm going to rewrite the square root of x as x to the 1/2. So we would multiply that power out in front, and then we would decrease that value by 1. So we get 3x to the negative 1/2 minus 10. And before we set that equal to 0, I will just rewrite this as 3 over the square root of x minus 10. And if I set this equal to 0, then I will figure out a maximum or minimum. So 10 would equal 3 over root x. Root x would equal 3 over 10. And so squaring both sides, I would get that x is equal to 9 over 100. Now sometimes when we're doing this, we're going to get a value that's not even within this interval. And if that's the case, we can just ignore that value because we don't care about anything else besides what's on this interval. So now what I like to do is I just like to make a small chart. So I'm going to put all the x values that I'm testing over here and all the y values that I'm testing over here. And like I was talking about earlier, we need to test both of the endpoints, 0 and 4, but also any critical points that we get within that interval. So we'll be testing 0, 9 over 100, and 4. And what we want to do is we want to plug each one of those values back into the original function to see which one's the largest and which one's the smallest. If we plug 0 in, we will get 0. If we plug 9 over 100 in, we'll get 0.9. And if we plug in 4, we will get negative 28. Okay, then it's really easy for us to say 0.9 is the largest y value, so this coordinate 0.9 over 100 comma 0.9 would be our maximum, our absolute maximum on this interval, and the smallest y value is negative 28. So this would be our absolute minimum on the interval. If you have any questions, please let me know. This will be the last video I create unless anybody sends me an email about a specific question that they have. So please do if you do have any questions, and I will try to create some more videos. I hope this helped. You guys have a nice day.